In this lesson, I'm going to focus on all of the formulas that you need to know if you have a test on logarithms. So let's go ahead and begin. The first one is this equation. Log AB is equal to log A plus log B. This formula is useful anytime you need to expand a log into two logs, or if you need to condense two logs into a single log. The next one is log A over B is equal to log A minus log B. The application is the same as the first one. It's useful whenever you need to expand or condense logarithms. Next, we have log A raised to the B is equal to B log A. So what you can do is, anytime you have an exponent, you can move it to the front, giving you this formula. For those of you who want to quickly access my Math and Science video playlists, feel free to check out the website video-tutor.net. You'll find playlists on algebra, geometry, trig, pre-cal, calculus, general chemistry, organic chemistry, physics, statistics, and other topics as well. And you can also access my final exam review videos on this website, in addition to my test prep videos. And there's some other links that you can explore here as well, so feel free to take a look at that when you get a chance. Now, something that you always want to know, log 1 is always equal to 0, regardless of whatever is the base. So for instance, log base 5 of 1 is 0. Log base 8 of 1 is 0. Log base A of A is always 1. If these two are the same, the answer is going to be 1. A raised to the log base A of log B, this is just going to be B. In other words, the A's are going to cancel and it simply equals to B. Now let's say if you have this equation, log base A of B is equal to C. Here's the formula you need to convert it from logarithmic form to exponential form. A raised to the C is equal to B. So using that, you can interconvert between the exponential and logarithmic forms of these two equations. The last one you need to be familiar with is the change of base formula. Log base A of B is equal to log B over log A. Now, notice that the base was initially A. This equation will work with any new base that you choose. The new base, we'll call it C. So as an example, let's say if we have log base 3 of 5. This is equal to log 5 over log 3. Now, this could be base 4, it could be base 7. It doesn't matter what the base is. The equation's going to work. Now, you need to know the difference between logs and natural logs. So let's say if we have log x and natural log x. Natural log, the base of a natural log function is always e. So if you don't see it, it's always e. And e is a number which is approximately 2.718. Now, log can have any base. This could be base 4, it could be base 7, it could be base 9. However, if you don't see a number, it's assumed to be base 10. So if you see log y and there's no base, it's assumed to be base 10. If you see log 4z, then that's the base, it's 4. So if it's not specified, the base is always 10 for logs. And for natural logs, the base is always e. The equations that apply for logs also apply for natural logs. So you want to keep that in mind. And that's basically it for this video. So those are the main formulas that you need to know if you have a test on logs. By the way, for those of you who want to put these formulas to practice, feel free to check out the links in the description section below. So if you click on more, you'll get access to other related content on examples like how to evaluate logs, how to change it from log to exponential form, how to use the change of base formula, how to expand and condense logs. We have solving exponential equations in addition to logarithmic equations, as well as graphing those two types of functions. And of course, there's a quiz at the end with some word problems. So feel free to take a look at that when you get a chance. It's going to be very useful if you're studying for an upcoming test.